This is problem 129 of Neetcode 150, valid parentheses string. So we are going to be given a string containing three types of characters, either an opening or closing parentheses, or a star. So we are going to have to return true if the string is composed of a valid sequence of parentheses. Otherwise, we're going to have to return false. So I think you might have an idea of what is a valid pair of parentheses. So if I just go here quickly and draw some examples. So would you say that these are a valid string of parentheses? Well, yes, right? So this is a big yes. Because we know that basically it's the same thing as when you write code. When you write code, you want an opening parentheses to be closed, and you want basically each closed parentheses to have an open parentheses before it. So for example, yes or no for this. Well, obviously no, right? So, because we don't have an open parentheses for the closing parentheses. We're in fact starting with the closing parentheses, which obviously doesn't work. So I think you have an idea. But now what if we have something that looks like, and now let me just write this down. So what if we have something that looks like this? What would you say? So I might have not specified, but a star can be replaced by an open or a close or an empty string. So we're pretty much free to decide what we want to do here. For example, we could turn the first star into an open parentheses, and we can turn the second star for a closed parentheses. Okay, and then we can turn the third star for an open parentheses, and the last star. Well, we notice that they are pretty much all paired, so we can just turn this into an empty string. So that will be a yes. Okay. So we're gonna use a greedy approach for this problem. So we're gonna solve that in a linear time complexity. Let me just show you how I came to this solution. So let's say that we have this basic solution, and we're just being asked to find whether or not this is a valid pair of parentheses. Well, we can already say that it is, right? Because every single open parentheses has a closed parentheses, and they are in order. So what could we do exactly to find this? So simple logic will be just go through every single characters, and if it is a closed parentheses, add one to a variable. If it is a closed parentheses, remove one from it. So this will help us keep track of how many open parentheses do we have. So let's say this is an open parentheses. It's like if we open a deal. So we are gonna add one here. So we're gonna rate that, then we're gonna go see the other one. We have another deal, another open parentheses. So now we're gonna be at 2. So now we know that we have 2 open parentheses that needs to be closed. And now we're gonna go see this one, which is a closed parentheses. So now we know that we are gonna close one of the 2 open parentheses that have yet to be closed. So now we have this here, which is an open parentheses. So we are gonna create basically another deal. If I keep my example, so now we have 2, right? So we know we have 2 open parentheses that haven't been closed yet. Now we're gonna go see this one. It's a closed parentheses, so we're gonna remove 1 to this. So we're gonna be at 1. So now we know that we have 1 closed parentheses that should be well, we have 1 open parentheses that needs to be closed. So when we go see this one, which is a closed parentheses, we're gonna basically remove 1 to L, which is gonna end up being 0. And at the end, if this is 0, we're good to go. If this is not 0, there's a problem. Either there's a closed parentheses that is just not paired with an open one, or there's an open one that is not closed. So we're going to use something similar for the problem with the stars. So instead of having only one L where we keep a value of 1 or 0 or 2 or whatever the value appears to be, we're going to have 2. We're going to have the minimum and a maximum. And basically, when we have a star, we can make this a close parentheses, which will basically be a -1, right? In our example that we just did, this was a -1. But we can also turn this in a closed parentheses, in an open parentheses, which will end up being a +1. So in our max, basically, we're going to have a +1, and our min, we're going to have the -1. And here, the trick is that the min can be in the negative as long as the max is in the positive, because the max will basically tell us that if we turn every stars into an open parentheses, we will have basically this amount of open parentheses available for us to close. So this is what we're going to do. Let's just go through the example. So we're going to go through the first character. We're going to have an open parentheses. So we won't have the choice to add 1 to the minimum and the maximum, because in both case, well, we have an open parentheses, so there's nothing else we can do. And now we're going to go see the second character, which is a closed parentheses. So instead of having 1, we're going to have a 0. So we're going to subtract 1 in the minimum and the maximum. Okay, and let me just erase that and rewrite it. So it's going to be cleaner. So we're at 0. And we're at 0. And now we have a star, which is the third character. So what this can be turned in, it can be turned in a closed parentheses or an open parentheses, meaning that the minimum value will be basically the consideration of placing this star as, or updating the star as a closed parentheses, while the maximum value will be taking into account the possibility of turning this star into an open parentheses. So it's going to be 1. Okay. Yes, of course, this value can be turned into an empty string, but we're going to handle that later. And what we're going to do is that if the maximum value is equal or greater than 0, but the minimum value is in a negative, well, this is okay, because what we're going to do at the end, if the minimum is negative, is that we are just going to turn this in a 0, as long as the maximum is not in a negative. So we're going to turn this as a 0, and we're going to go see the next character, which is closed parentheses. So now the minimum will be -1, and the maximum will be 0, meaning that if we turn every single star so far into an open parentheses, we will have at this point a maximum of 0 open parentheses that have yet, or that haven't been closed so far. Okay. So this is okay. This is fine. There is no problem of having no open parentheses that are not closed, as long as we don't have another closed parentheses that comes right after this. So now the minimum value is -1 again. So this is fine. We're going to turn this in a 0 again, as long as the maximum is not in a negative. And now we're going to go see the last character, and we have a star, and a star can be turned in an open or closed parentheses, which will result in -1 and 1 respectively. So now we can see that if we turn every star into an open parentheses, we will end up having basically an extra open parentheses. So that will become an open parentheses, and that will become an open parentheses. So this is not what we want, but we know that we have basically enough parentheses to compete with our closed parentheses. So this is good. It's better to have too much than not enough. If the minimum value is in a negative, we're going to turn that into 0, which is perfect, because the minimum value gotta be 0 at the end. It is possible though that if this was not a star but was a strict closed parentheses, well, that will not have worked, right? That will not have worked, because our max will have been in a negative at this very position. So this will have basically give us an invalid combination. But what if these two were open parentheses? What if that was an open one and that was also an open one? Let's just go again through this process really quickly, I promise. So we know that at first we're going to have an open bracket, which is going to give us a 1 for the minimum and the maximum. Then we have a closed bracket, which will which will subtract 1 to the minimum and the maximum. So we're going to be at 0 again. And now we have basically 2 consecutive open brackets. So we're going to add 1 and 1 respectively. So we're going to be at 2 for the minimum and at 2 for the maximum. But then we have a star. So a star can be converted to a close or an open parentheses. So we are going to subtract 1 to the minimum and add 1 to the maximum. So the minimum will be 1 and the maximum will be 3. Meaning that at the minimum, if we turn every single star into a closed parentheses, there will still be 1 open parentheses that haven't been matched, that haven't been closed. So this is not correct. And the maximum is 3, okay? So what you have to care about is that the maximum never gets negative and that the minimum ends up being 0. So let's go ahead and apply this exact same logic. So what I will do is that I will create an L min and an L max. Both will initially be equal to 0. And then I will go for every single characters inside a string, so for C and S. And I will ask myself if C is an open parentheses. I will basically add 1 to the L min and the L max. What if this C, instead of being an open parentheses, is a closed parentheses? Then I'm going to have to subtract 1 to the L min and to the L max. What if it is something else, meaning a star? The L min will be decremented by 1, and the L max will be incremented by 1. And now on each round, if the L max is in the negative, it means that basically we have an invalid combination. So we're either starting with a closed parentheses, or basically there's too much closed parentheses for the number of open parentheses at this particular place. So in this case, we are going to return false. This is the first case where we want to return false. And now if the L min is in a negative, this is where we want to convert this into 0. So L min is going to be equal to 0. And this check has to be done after the first check. Because if L max is equal or greater than 0, well, we can safely turn our L min into 0. And now we can return the L min is equal to 0, which is basically what we expect to have at the end if we have a valid string of parentheses. And this is going to tell us whether or not the solution is working. So that's good. Notice that we are not storing everything. So we don't have any additional memory complexity. Hence, our time complexity is big O of 1. And for a space complexity, for a time complexity, we are going once through every single character in the string S, meaning that if n is the length of S, we are going to have a time complexity of big O of n. With that being said, I hope you enjoyed the video, and I hope to see you in the next one.